Okay, so now we're going to talk about combinations. Number of combinations of and distinct objects taken on R at a time. So you can see it's the same, basically the same thing as permutations. The only difference is the order is not important. That's the main key thing to decide whether something's a permutation or combination. Order matters for permutation, order does not matter for combination. The difference in this formula is they divide by R factorial, and what that does is it gets rid of instances where you have the same thing being labeled twice. So what I mean is, if you order a pepperoni and mushroom pizza or a mushroom and pepperoni pizza, you have ordered the same pizza. So either way, you're going to get one representative for both of those things. If you have 3 toppings, there are 6 different outcomes. So pepperoni and mushroom and bell pepper, pepperoni, bell pepper and mushroom, and then just keep rearranging those words until you have all 6 of them. If you order any of those 6 items, you will get the same pizza, regardless of what you say. Hold on, what is going on here? Oh, okay, I went the wrong way. So what you try to do to remember combinations is order doesn't matter as you think of a combination pizza, and that the fact that no matter what you say for the toppings, they're going to give you the same pizza, or what order you say the pizza toppings, they'll give you the same thing. Okay, so if you want to do this on a calculator, same thing, math, go to probability and choose R, and 5 choose 2 in that example is 10, and so decide if it doesn't matter. If it does, then obviously it's permutation. How many different simple random samples can be chosen of size 4 of a population whose size is 20? Well, that's pretty straightforward. This is obviously a combination, because if you choose 1, 2, 3, and 4, or if you choose 2, 1, 3, and 4, 4, 1, 3, and 2, 4, 2, 3, 1, and 4, 3, 2, 1, and whatever, so on and so forth. I think there are 16. You have chosen the same simple random sample. So let's go and do this real quick. So I need to erase this. So if we do 20 choose 4, then that's 20 factorial over 4 factorial times 20 minus 4 factorial. Oops, I put that in the wrong spot. So if we do the math, this is 20 times 19 times 18 times 17 times 16 factorial, all over 4 times 3 times 2 times 1 times 16 factorial. So this is 5, this is 6, it goes into 18 3 times. So 5, we're doing, let me do it on a calculator. We have 5 times 19 times 3 times 17 is 4845. There are 4,845 ways we can do this. Choose different random samples, unique random samples, okay? So that we don't have overlap of the same exact things multiple times, just in a different order they were chosen. So let's go ahead and continue on. Solving problems involving non-distinct items. These are your types of problems where you have, like, Mississippi. Notice that Mississippi has a couple S's, a couple I's, and P's that are all repeated. And you can still rearrange them, but you can't distinguish which I is being used. And therefore, we can deal with that by using the non-distinct formula. So how many different vertical arrangement are there of 10 flags if 5 are white, 3 are blue, and 2 are red? If we want to do that, then what that formula just said was we have 10 factorial over 5 blue, or was it 5 white? It doesn't matter. 5 white, 3 blue, 2 red. So 5, 3, and 2. Oops. 5, 3 factorial, 2 factorial. So this is 10 times 9 times 8 times 7 times 6 times 5 factorial. Always choose 5 factorial. So always, what the heck? Always make sure you choose the bigger factorial to cancel from. So 5 factorial. 3 times 2 times 1. And 2 times 1, we're multiplying all this, by the way, cancels. This is 6, cancels. This is 2, 2 goes into 10 5 times, so this is 5 times 9 times 8 times 7, which turns out to be 2,520. Okay, so that is taken care of. Okay, so let's keep going. We've got that one solved. Just a summary of formulas. We have combination. N choose R is obvious. These are just formulas, guys. Permutation with distinct items with replacement is just N to the R. Permutations of distinct items without replacement is just NPR, which is the permutation formula. And then permutations of non-distinct items with replacement is obviously the formula we just used. So for the next videos, we are going to get into which one do I use when, and we'll obviously use tactics to figure these things out. Thank you guys for watching. I think that, oh, that's not it. Sorry, I thought that was it. In the Illinois lottery, there are balls numbered from 1 to 52. An urn of 6 balls are randomly chosen without replacement. For a $1 bet, a player chooses sets of 6 balls to win, and all 6 balls must be chosen. The order in which the balls are chosen does not matter. What is the probability of winning the lottery? So let's do this real quick. We have we have 52 numbers. Order does not matter, and therefore the number of choices, so there's 52, choose 6 ways, but there's only one way to win, right? You have to choose your numbers, and no matter what order you choose that set of numbers, no matter what way you choose that set of numbers, it's always going to list them from smallest to highest, or lowest value to highest value. And so there's only one way to pick that ticket. And then you have 52, choose 6. So if we do that on the calculator, we're just going to simply go math and choose R because order doesn't matter. 52, choose 6. That's a really big number. This is going to be Where is it? Hold on. This one. 20358 20 520. We have a 1 out of that number, 20,358,520 chance of winning this lottery. Okay, and so that would be your chances for that. A shipment of 120 fasteners that contains 4 defective fasteners was sent. The plant's quality control manager randomly selects and inspects 5. What is the probability of exactly 1 of the inspected fasteners is defective? So we must first choose exactly 1 of the fasteners to be defective, and then choose the remaining 4 of the functioning 116 to be functional. So let's we can do a box with this. So what I'm going to do, let's use a box. So we have to choose 5 of them. This is the defective one. And then these are the remaining ones. Working. We need working ones. So we have to choose 1 defective one. So we're preloading this. There's going to be 4 in here technically. So this is an order of 5 or a checking 5. So we have a 4 choose 1 chance that this one is defective. Any of the 4 broken ones will suffice. And then the rest need to work. So we have 116 that work. Choose 4 of them. Okay, so if we multiply this together, this is 4 times 116, choose 4, which is math. This one, 116, choose 4, and then enter. times 4. There are that many ways to do this one. Okay, there are 28 million ways to do that. Okay, so that is taken care of. And that is that. Make sure you try the student practice for this before you move on. There is a Kahoot on here. Obviously, we probably aren't going to do it. But with that being said, I hope that you guys are practicing. This is probably one of the more challenging things you're going to do so far.